Okay, it's just one quick volume question here. The sand in this hourglass takes up 3/4 of the volume of the bottom cone. Part A, calculate correct to the nearest cubic centimetre the volume of sand in the hourglass. B, if the sand takes 1 hour to fall from the top cone to the bottom cone, at what rate is it falling? Give your answer in cubic centimetre per second. Correct to 2 significant figures. Okay, the first part, let's have a look. I'm just going to draw this part again here. So, part A. So, I'm just going to draw the bottom cone here and then with sand in it. Okay, so that was, the diameter was 20 centimeters. Now let's think about the height of each cone. So the whole thing was 2 cones is a 50, so half, so 25 centimeters. Okay, so that wasn't too bad. And radius obviously is 10, so h equals 25, r equals 10 centimeters. Okay, so that's sorted. Now, how are we going to find that volume of sand? So I'm just going to go volume of sand equals, how about we think about this as one whole thing, take away the little cone on the top with no sand in it, will give us the rest, which is the volume with the sand in it. Okay, so I'm going to go volume of cone take away volume of cone 1/4 of it. Yep, that makes sense, doesn't it? Okay, so that's what I'm going to do. Gotta push up a little bit. Let's start. So I'm going to use different color. So let's have a look. Volume of a cone. Do you remember the formula, guys? So I think it's 1/3 pi r square h for the cone, because the bottom base shape is the circle, so it's a pi r square, and the height. So 1/3 times pi times r is 10 square times the height is 25. Now that's just the whole cone. Now we've got to do 1/4 of that. Everything is exactly the same, but we just want 1/4 of it. Oops, square. Okay, so if you put all that in your calculator, you will get 1963.495 ... and cubic centimeters. Okay, so that's not too bad. And then part B now, I'm going to push the question down a bit, and then now we know what part B is, what we have to do. Part B says find the rate, okay, cubic centimeters per second. Now what we've got from the part A is 1963.495 ... cubic centimeters. If we want to change that into rate, is per hour, because the question says it'll take 1 hour to fall. Okay, so I need to, all I have to do is change that to second. That's all I have to do. So what I'm going to do is I'm going to draw some diagram about changing, conversion diagram, hour to minute, minute to second. Now, how many minutes in 1 hour? 60. How many seconds in 1 minute? 60. But if I go back to it, it'll be divided by 60, divided by 60. Now, we want hour to second. So hour to second will be times by 60 times by 60, which is, guys, 60 squared. Okay, so that's what we got to do. So back to the question. I'm just going to go 1963.495. I'm going to use these, okay, not 1963, because to be, I just want to be more accurate. So I don't want to have the nearest cubic centimeter. I want the maybe 2 or 3 decimal place value. Centimeters cube is 1 hour, okay, at the moment, and I want to convert that to seconds. So 1963.495 centimeters cube is still the same. Now on the bottom here, I'm going to change the 1 hour to 60 times 60, and that'll become second. Okay, so I hope that you can see what I'm doing there. And if you put that in your calculator, you will get something like 0.55. I'm just doing it 0.55 because I want it to be 2 significant figures. But let's have a look while we add it. So I'm going to put 1963.495 divided by 60 times 60. So we can see 0.545415 ... So we want 2 significant figures. So we want rest is gone. We just 2 decimal places here. But the third value is 5 or bigger than 5. Then it will go up. So that's why I'm writing 0.55 cubic centimeters per second into 2 significant figures. Okay, well that's what it is. Well done.